Okay, let's look at number 5. 5 is the same thing we've been doing. They just throw in a couple of curveballs and make it a little bit different. So, in 1979, Dr. Hans Leibold of Germany drove a car 1.26 times 10 to the 4th meters with an average speed of 112 meters per second. Suppose Leibold applied the brakes to reduce his speed. What was the car's final speed if 3 megajoules of work was done by the brakes? Assume the combined mass of the car and the driver to be 1 times 10 to the 3 kilograms. Okay, that's a mouthful. That's a lot of stuff there. Let's focus in. That's a lot. There it is. Let's get a good focus going. It's solid. It's the same. Okay, so let's write down what we got, and then let's go over this question before we even get started. I'm not going to go over distance, but I am going to go over velocity. Velocity equals 112 meters per second. So that's saying, he drove with an average velocity of 112 meters per second. Awesome. The car's final speed. What was the car's final speed if blah, blah, blah work was done? Okay, so work equals, remember, he applied the brakes, right, to reduce his speed. So what does that mean about work? That means work was negative, right, because it slowed it down. So I'm just going to put negative 3 megajoules. You're going to need to convert that to joules, just FYI, okay? And yes, you have to convert that work, blah, blah, blah. Combined mass, man, this is a lot of stuff. 1, 0 times 10 to the 3 kilograms. Okay. That was a lot. That was a lot. This is true. Okay, so let's start with formula. Oh man, this problem's making me go to sleep. Work equals 1/2 times mass times final velocity squared minus 1/2 times mass times initial velocity squared. Alright, let's plug in. Remember, they gave us work, negative 3.0 times 10 to the 6 joules, right? That's converted for you. Equals 1/2 times mass, which is 1.0 times 10 to the 3. You're going to have a lot of these scientific notation things, so you're going to have to calculate this junk. Times velocity, final velocity squared, minus 1/2. Same mass, 1.0 times 10 to the 3. Parenthesis that, so it kind of stays together. And then our initial velocity is 112, and then we got to square it. Okay, I need to put initial velocity here. There we go. There we go. Now we got the dot. All right, cool. That is a lot of stuff. Okay, so let's rewrite this. Let's combine stuff. Negative 3.0 times 10 to the 6. 10 to the 6. That's our work. Equals. So 1/2. 1 times 10 to the 3 means you move it 1, 2, 3. So that's 1,000, right? Times 1/2. That's 500. Times final velocity squared. Okay, so that's good. Minus, same thing, 500. 1/2 times 1,000, that's 500. Times 112 squared, which is, I forgot to get my phone. Oh man, I guess I got to do it. 112, 4, 2, 2, add a 0, 2, 1, 1, 4, 4, 3, 1. Ugh. Bring a calculator when you do physics. It's not fun when you don't. So, 13 44. 1344. Yeah, I should have just got a calculator. That would have been so much easier. So let's combine that. So it's going to be minus 6.272 times 10 to the 6. 10 to the 6. And then 500 final velocity squared equals minus 3 times 10 to the 6. Ooh, there we go. Okay, so first thing we need to do, this is all like broken up. This isn't like times some variable, so we can just straight up plus 6.272 times 10 to the 6. Let's just, boom, gone. Plus 6.272 times 10 to the 6. Okay, so we can combine that up, right? So I guess, do I get enough room? Yeah, I got plenty of room. I'm going to start right over here. All right, so now we got 3.272 times 10 to the 6 equals 500, same, everything's the same on this left side here, times velocity squared, right? Final velocity squared. So it's multiplying, it's divided out. Divided by 500. Divided by 500. Okay. So I'm running out of room. Let's go, I guess we're going to go above. That way we're not jumping around too much. So we've divided it out. We should get 6544 equals final velocity squared. Do you remember how to get rid of that square? Hopefully you do. You got to square root it, which means you got to square root this side. So I'm going to flip it. I'm going to draw this arrow so we know it's right down here is the final answer. Final velocity equals the square root of 6544. Calculate that. 80.895 is about what you get. You can round this if you want. Maybe 80.9, something like that. But meters per second. So that is our final velocity. Ooh. So this is our final answer. Bam. Okay. Whew. A lot of work, but really not. I mean, it's just big numbers. Not too much more work than any other problem. Okay. Well, there you go. That's how to do this one. The next one's just about the same. You got to figure it out. Except for the next one's mass. I think they give you what? Number 6, they give you the work. They give you the final velocity. They give you the initial velocity. Oh yeah, the next one's easy. The next one's easy. Number 7. Number 7 looks easy too. Legit, it looks easy. You just got to convert some stuff. Number 8, net work. Number 8's easy too. Awesome. You guys are all set. I did the hard one. You guys got to just do the easy one. Cool. All right. Good job.